Hi everyone, my name is Alex, and today we're going to have a talk about hurricanes and the underrated importance of epidemiology in tracking storms, their health outcomes, and many other factors. Hurricanes are a natural environmental outcome that can't really be controlled by humans. As much as data and data sciences like epidemiology can be tied into, preventing outcomes and tracking data from past outcomes and applying it to future outcomes, but you can't really, there's some things that you just can't track and control, and things like that is you can use evidence from the past, and like I said, evidence of the past to predict the specifics of a storm. In other words, the who, the what, the where, the when. So who's it going to affect? What is it going to, what are the outcomes going to be of it? What's potentially going to go wrong? Where it's going to affect. So you're going to have a specific location, maybe a specific, a specific square mile range. And the when, how long is the storm going to last? Is it going to last a certain amount of hours? Is it going to last 2 days? You never really know. And that's really where the use of the underlying epidemiology kind of makes itself clear for maybe a topic that some people maybe wouldn't on the surface think uses it a lot. But when it comes to hurricanes, there are things that just can't be controlled like humans, like I said. For example, a factor like the strength of a given storm season cannot be predicted and furthermore controlled. So you may be asking, how do state and public health departments plan and prepare for storms like that? Well, to break it down, the CDC, through the National Syndromic Surveillance Program, will provide almost real-time data to adapt to the constantly changing environments, because you never know because the environmental conditions, the wind, the amount of rain, the amount of flooding, the risk for flash floods or mudslides, depending on the location, all those factors are constantly changing and shifting based on what the environment's doing. So the amount of data that they are able to produce at almost real time makes those outcomes just that little bit more likely to maybe not end up as negative and maybe a little bit more positive. Normal surveillance procedures just wouldn't be able to do that. They'd be taken from older data, so maybe a little bit skewed data, not necessarily biased, but just a little bit skewed data, but in changing the response by the public health officials who are, coordinating all potential evacuations and organization of resources for people who need it. And once again, with the help of the CDC, local health officials use disaster epidemiology specifically to evaluate short and long-term, consequences and effects of disasters and potentially saving a lot of lives. And they're able to predict the consequences of the future. So, potentially financial outcomes, how much is it going to cost to rebuild a city infrastructure depending on how much is damaged, because all these hurricanes are ripping through here. They're doing millions on billions of dollars of damage. So you're going to have to some degree be able to estimate that and start maybe financing and budgeting that as soon as possible. So having information like that is ideal to predict for the future and set yourself up well. The CDC also highlighted from a specific example, potentially saving a lot of lives. Post-Hurricane Harvey in 2017, syndromic surveillance showed the increase for need of those 1 to 4 hours outside the direct disaster area, so a bigger range than potentially was predicted at first. And with that disaster data, that disaster epidemiology and the syndromic surveillance, you're going to have a lot better data to act on, and information like this during a normal time of crisis under normal surveillance could have resulted in a lot bigger disaster and a much bigger loss of life. To continue on describing the deeper connection between epidemiology and tracking hurricanes, I can talk about when you're doing epidemiology specifically in assignments so far this semester, we've had to do root cause analyses. So find just the root cause of why things are the way they are, and maybe looking for trends in your data or whatever, and seeing what those trends are contributing to. Specifically for this example, the trend of the strength of Atlantic hurricanes in the 21st century has gone significantly up. So people that track the storms, meteorologists, other epidemiologists that are also tracking that are also tracking the data about these storms, they all look at it and they also see what's going up simultaneously is climate change. Climate change and global warming, whatever term you'd like to use, those two, or that process contributes to a higher atmospheric temperature, and that's all going to contribute to higher wind speeds and more violent conditions overall. So more hail, potentially like sleet, more rain, more dangerous flooding, thunder, lightning, all those kind of conditions that are going to be, followed with a hurricane and be really, really dangerous for a community that might be affected by a hurricane. To speak further on the subject of the effect of climate change on the strength of hurricanes in the Atlantic, we brought in Daniel Guilford from Climate Central to talk about the true impact that man-made climate change is having on the strength of hurricanes in the Atlantic.
These warm temperatures can provide a catalyst for storms to become very intense very quickly, and even very early on or even later into the season when storms aren't expected to be as intense, but indeed are becoming that intense.
Daniel Guilford, a climate scientist with Climate Central, says we know warmer ocean temperatures are fueling stronger storms. Rising sea levels can bring higher storm surge, and a warmer atmosphere allows heavier rainfall.
As these sea surface temperatures continue to warm across our planet, we are seeing more tropical cyclones have stronger intensities associated with these because the speed limits of the storm are going up, so storms can actually reach higher intensities than they otherwise would have been if we hadn't warmed the planet.
On the screen here, I'm going to show a graph from the U.S. Environmental Protection Agency that's going to consistently show the rise in temperature of the surface of the sea, so the surface of the seawater, and the increased strength of the hurricanes from 0 to 6 on the hurricane strength index. And that's going to further prove a little bit of the strength of the relationship between climate change and strength of hurricanes. After reviewing both the real-time and analytical purposes of EPI and how it ties into hurricanes, I think it's time to talk about damage control with hurricanes, because obviously that's the name of the game with them, and all other natural disasters is damage. Groups like the CDC and the National Institute of Health keep tabs on anywhere that has not only had events like hurricanes, but also anywhere that's experienced flash flooding. Floods during hurricanes are the leading cause of waterborne outbreaks in these places after the storm subsides. Diseases such as West Nile, cholera, Zika virus, all waterborne things. Hurricane Harvey in Texas, specifically, the NIH conducted a study on a Clear Lake system in Texas. I'm going to throw it up on the screen, the study. And they found that before there was super low levels of fecal, the fecal matter bacteria in the water, and that was going through the water system. So that was obviously really good. But then after the storm, it took 2 months for the levels to go back down to normal because they were so high and there was such a dangerous level of the bacteria. It's called fecal indicator bacteria in the water systems. And without data like that and disaster epidemiology, like I had mentioned, which is not only for real time and before, but also after, the disaster loss of life rate could have been significantly worse than it was. Now, I know I mentioned that one of the main principles of EPI is main ideas behind EPI is finding the root cause, or why as to why something's happening. And for disasters like this, it's not just about that. It's looking at the trends that happen afterwards, so specific health outcomes. And I'll throw it on the screen in 2.5 seconds or something like that. It's gonna be a map of Texas post Hurricane Harvey, so 2017. It's gonna show different areas and the different levels of flooding and where different trends of the density and quantity of people visiting the emergency room and the emergency department after after the subsiding of the storm. Just probably that will that will show an epidemiologic trend of, you know, people maybe dealing with injuries, outbreaks, waterborne, foodborne, anything like that. So being able to track trends like that is super, super important for him being able to not only stop them from evolving even further, but preventing them from happening in the future. That map was courtesy of the Journal of Exposure Science and Environmental Epidemiology, and I think it does a really good job of just showing, you know, the relationship between all those adverse floods and just, you know, disastrous health outcomes, and the increased rate of ED ED visits. It really shows the strength of that relationship. Shows how Epi can be really used, and other than that, that's gonna call it a night for us from Alex Pennington News here at Bridgewater State. I appreciate everybody for watching, and hopefully everyone learned a little bit something new today.